Okay. All right. So now I will be sharing a link to the quiz. Welcome, you're welcome. Williams, Wachi, you're welcome. Adini, Dada, you're welcome. All right. So I'll be sharing a link to the chat. Just pick it from there, and I'll also share the number that we'll be working with. Okay, the needed number for the quiz. You know, when you log in with the link, though, it's required that you log in with a number. So just give me a minute. Okay. It's coming up. So that is just a very short quiz, very simple one. Right. So okay. Okay, so let's enter it. We're about starting. $379. All right, class. So that's the link for the quiz. That's the link for the quiz. I'll be expecting us there. Just within 10 minutes maximum, we'll be done with the quiz. All right, so if you have any challenge, let me know. Let me know. So if we start entering, I'll be seeing us. Following somebody which we are running a quiz, a quick quiz. Okay. So we're running a quick quiz. Please, can we? I'm expecting us on sheet. I'm expecting us. You can unmute if you have any challenge, let me know. And if you have joined, you can also unmute, let me know. But I'm tracing from here. Hello, Olayinka, Samuel, Williams, Anthony. Have you joined? Okay, I'm seeing one person. So let's join. Who just joined? Let me know.
Good afternoon.
If you join, Williams, you joined, right? Hello, Williams.
Yeah, good afternoon.
Okay, thank you. All right, I'm waiting for.
This is the first time I'm joining. I don't know about.
It's not a very difficult quiz. It's just fun. Don't worry about it. It's fun. They are very easy questions. Yeah.
Okay.
So let's join in. They are very easy questions.
Okay.
It's just for the fun.
Okay.
So just one person, and even if it's one person, by 4:08 I'll be starting because it's around 7 minutes quiz. Because I will appreciate that's I will make it fun, more fun. Okay, somebody is saying something. Samuel. Bye. Hello, Samuel. If you're speaking, I can't hear you. Adini, that you can also join us. It's just for the fun of it. All right. All right. So I will be starting the quiz right away. I know some of us don't just hear anything quiz. It's something that is for it's for fun. So you can see what I wrote there. Don't worry, it's just a bit of fun. If you can see my screen, I mean, you can see what I'm presenting. Let me know. But I most likely, if you have logged in, the person that have logged in will be seeing. Then, all right. So I'll move. So please join the quiz. I know you'll be seeing. Please join the quiz on your own screen too. So I have just things around it. Now, are you ready for the first question? 1 of 12. Just 10 seconds. Loading up. Loading up. Loading up. Okay. Going. Okay. Go to the next question. Are you ready for the next question? Okay, I have it. Then, what's the data? A or B? Someone has voted very well. Great. Good. Okay, you get the answer. Next question. Ready? Okay, coming up, coming up. What does GIS mean? What does GIS stands for? Oh, great, 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 great. See what? Next. Observe remote sensing of biophysical contact. True or false? Okay. Going, going. All right. That voted. Let's move on. Now, ready for the last. Which of the following is an example of vector project? Vector data, satellite, imagery, okay, the control line, the television model. Okay, somebody picks. Okay, right, 6 of 12. It's going, as fast as you, okay, statistical data can only be represented in a raster format. All of us. Okay. Oh, I have 2 persons now. It's interesting, right? Then it's coming, it's coming, it's coming, it's coming, it's coming. In remote sensing, what does the term resolution refer to? What does it? All right, great. Now, now question 7. Raster data. This is the question. All right. Raster data is made up of points, lines, and polygons. True or false? Everyone has voted. Okay, next, next. 9 of 12 now. Hmm, 1 minute. I'm less than 1 minute. Which of the following is an example of open source GIS tool? Yeah. Okay, everyone has voted. All right. So 10 of 12. 10 of 12. So turn off loads, and here you have it on your screen. Bam. So the following is an example of a vector data format in GIS. 4 seconds, everyone has voted. What's the result? Oh, okay. Let's go to the 11 of 12. Okay. Which of the following is an example of raster data format? Yeah. Seconds, 4 seconds, great. The last, and the last one. Okay, I have a question, top of 12. And it comes, and here you have it on the screen. Like GIS tools or feature can be used to automate repetitive GIS tasks. Very easy, and it's okay. All right. So the next thing you will see on the screen, because now permit me, I think I can see your score, but you permit me to share my screen now. So I can show you the winner. I want to show us the winner. Okay. Somewhere I come doing up to this. Very fun. And the other person score 194. Samuel Ekong score. Samuel won the quiz with 427 points. Then let me show you my last slide on this. The last test is well done to the winner. Let's clap ourselves. Thank you so much. That takes me to our class. Thank you for participating in this quiz. And it was, can you see that they are just very interesting thing. Okay, I'll just stop sharing so that we can have out of this class. All right, so welcome once again to this class. This is geospatial webinar, bi-weekly webinar, and what we'll be looking at today is Earth observation embeddings from scenes to vectors with foundation models. All right. So, and the mother body of the organization holding this is Data Science Nigeria DSN. And our commitment is to raise 1 million AI talent, and build AI solutions that improve quality of life, and well-being in the of 2 billion people in the emerging market. So, and this sub group, the sub C under this organization handling this webinar is geospatial team, and without wasting our time, it's geospatial community. Yes, that where we belong to. So if you have not joined, please do join. I will drop the link to the community. There are groups of professionals where we meet, you will connect and do a lot of things. So, and then not just only teaching, you'll get to connect with other professionals. Thank you. So because of a lot of time that we still have to save ourselves, so we are diving into today's class, and I bring in our facilitator for today. She is a powerful machine learning engineer, geospatial machine learning engineer and data analytics, whatever it is. Sorry. All right. So, and I bring on our facilitator, person of Sarah Peter Adeoye. Welcome, Sarah.
Thank you so much, Blessing, for that introduction. So, because of our time, okay, good afternoon, everyone, depending on where you're joining us from. My name is Sarah Peter Adeoye, and I work here. I am glad to be your facilitator for today's training session. Satellite embeddings, we get to understand what satellite embeddings is. Before you get to know what satellite embeddings are, we'll be a brief recap on what are geospatial data we have, before we now go straight into what satellite embeddings are and So today, there are lots of use cases that we'll be treating, but for today, and we are going to use Google Earth Engine for this use case because it is an interactive, it's going to be an interactive class. So please join me as we journey. Thank you. So a brief recap on the geospatial data type. Okay, I just got notified. Okay, I think my net I think is back now. So everyone please feel free to unmute yourself. If you can raise up your hands, and my colleague Blessing would notify me that there's, or if you have any questions, you can also drop it on the chat so that I can answer, get lost or confused along the way. Please, let's take a deep dive back into a brief introduction on the geospatial data types that we have. So for that may not know, we have two main types of geospatial data, which are the data and the raster data. So let's go deep into what the vector data is. Then individual locations on the Earth's surface defined by a single set of coordinate locations of wells. Okay, the vector data has three types of data. We have the points, we have the lines, and we also have the individual locations. So if you see my screen here, on this right hand side, it's lagging. So it's not showing the slide that I am. So in the vector data, we have the points which represent the surface by a set of coordinates, which is the longitude. And the examples of the point features that we might have. We have location wells, locations of, okay, let's say Aso Rock now, for we that we are in Nigeria, by a set of coordinates, longitude and the latitude. And some of us are in our offices, some of us are at home. We can is also a point data, which is an individual location. So what are line features? They represent linear features that connect two or more points. Examples of these are rivers, roads, railway lines. They are line features. So polygons, we have for polygons, they represent area features enclosed by lines, closed shape. So if you see the image on my right hand, closed features here. So what are the examples of polygons? Example of polygon features are the boundary of Nigeria, for shape of Nigeria on the map of the shape of Nigeria, and boundary of your school, the shape of your school, or the shape of your church. We've talked about the vector data. Now let's go straight into the raster. In the raster data, the raster data stores of cells, which are rows and columns. Now, each of these are on the Earth's surface. Now, this raster also is defined cell spatial resolution, and the spatial resolution determines the details of the. Please excuse me, let me stop sharing and reshare again. Point of, like, I think it's okay like this because I'm getting feedback that my excuse me, So now, the purpose of us going brief recap on geospatial data is just to remind ourselves and have a glimpse on what we which is the satellite embeddings. Now, basically, this raster data, as you can see in this, what the raster data are, they store data in matrices of each cell contains or represents features on the Earth's surface. Like you see the image on the right, we have a here, and this square is being represented by these matrices of cells here, projected parts. So now to satellite embeddings. There's been a whole lot of satellite embeddings around, let's say since July. This provides new analysis ready data sets for people, and it is produced Google in collaboration with Google DeepMind, made use of AlphaEarth foundation model. So I'm going to break it down for you. We have different satellite data, such as Sentinel-1, Sentinel-2, Landsat, ERAS data, we have a whole lot of them. Now, all assets, before you can use them, all these images, you would need to go through some pre-processing steps to use them. Take, for instance, Landsat or Sentinel-2, the imagery now, satellite. Before you can use Sentinel-2 satellite imagery, you need to do cloud maps. There's definitely going to, now, especially during if you are or your date of interest and with the rainy season period. So there is this that there's going to be cloud cover. You know, when it's raining, the satellites won't be able to penetrate through the sky, through the large clouds to capture what is. That is what causes or results into cloud cover in our satellite imagery. So in most times you have to go through processing steps. Which one of those pre-processing steps for Sentinel-2 image cloud masking? That is removing the cloud cover in your data. Why this satellite embed very good or useful is that provides a analysis ready global data set. It is for all of the whole universe, like for the whole world, it's a global data set, and you don't need to pre-process. You don't need to do any pre-process. Also, one reason why this satellite embedding is that the model ingests time series of different data to produce a unified digital representation of each pixel. Explain better on that point as we move forward. So just on captures a whole, just say that, just look at it in this way, that the embeddings cap is produced by combining a satellite imageries together, and from different years we have in this data set, which was now combined together to produce these embeddings, all infused in the AlphaEarth foundation model, which was built by researchers, and from there it was trained on architecture to now produce these embeddings, which has learned from the time series from different years. Let's just say, so we have it here that for each year from 2017 data to 2000, and we have from 2017, we have 2018, 2019, 2020, 2023, 2024. 7-year span of daily imageries, depending on the and temporal resolution of this data set. Now, they combined the whole of Sentinel-2 and a whole lot of those images together to produce these satellite embeddings. Good, we'll see that. So this is a video, and I would love so that we understand is being done or what was done by all these people. So so please note, let me put it. Lesson, is it showing? Yes. So now what this is trying to say is that imagine the satellites in the orbit taking screenshots of this Earth at different resolutions, now being combined together. So let's go. This is the satellite in space taking all these readings, normal images. It's not playing. Okay. Playing. Let's see. Okay, let's see from here. Is it playing like this? Okay, so this was developed by Google DeepMind, and it is the satellite goes down, goes round several times, and see this chunk of images. It is now come together to produce these embeddings. So just imagine the number of, the amount of compute, the amount of resources that has gone in to produce this kind of embeddings. So much work again at all. So this has already shown the satellite rotates around the orbit, is to take snapshots of the Earth at several times, and different, it is showing different images. So as it is taking all these different images, combining all of them together into one, see where it is combining them into one embedding that is now representing future. So now one thing we need to know, so let's need to know, is that why are these embeddings special? Pixels are created from all Sentinel-2, like I have mentioned earlier, all Sentinel-SAT, all Landsat 8 imageries for the entire year. It also change satellites as well, like errors. It's also captured was like that gravity fields data, text information, and the light, just to produce we have right now as this satellite embeddings. Now, for better understanding, whenever you download a Sentinel, let's say for example Sentinel-2 imagery, you would have like 12 bands. Just imagine you adding these 12 bands as in this Sentinel and combining it with every other satellite, the Sentinel-1, the errors, the elevation, a whole lot of everything together just to now have one image that now has spans. These 64 outputs represent, so it is now like us having, so the image here, this represents the kind of data set that was used to train. And when we have both the optical, we have the thermal, we have the SAR, we have a lot of things that was combined together. And the band, if you see, Sentinel-1 has, let's say, 2, 4, 5. And Sentinel-2 imagery has different brands. It's combined at Landsat, ALOS, and combined everything. So it's combined, it was made up, it was trained with this amount of data sets. Now trying to understand this. Embeddings are compressed of a higher dimensional input. They are compressed. So all those that we have in all these imageries, there are lots. Just imagine compressing each of them. So if one thing we know, one thing about I could relate this to is principal component analysis, data analysis, whereby you have a whole lot of features together. You try features and give it to build the principal component analysis model and tell it the amount of features. You might even have thousands of features. You give it to the model and say, features that I have from these thousands of features that I have, help me create future from it. So it's going to combine everything together. It's going to and try to understand the futures. It's going to try to understand. It's going to understand each of those futures well. For it to say, oh, this is what this one that we can use to represent these thousands of futures you have given to me. Satellite embeddings is or can be better explained. Image I have here on my right hand side. So it's just saying that image just say these 3 layers now combined together to give you just one. And at this cell, it or see the embedding in this down cell. This embeddings is that they can be taught to represent a coordinate on a each cell. That means it now has 64 bands. We'll when we go as we continue, we'll get on our hands-on session, data sets, live and direct. And then I would also share some other case that we can use this data for. Now, another thing we need to know, embeddings are continuous and stored in an image format. You can treat of the embedding space just like spectral bands for visualization. It's very simple for those of us that are conversant with images. You know that whenever we download a raster image, there is always the bind together to get some of the features that we are interested in. So that okay, these satellite embeddings are in form of it's an image that has 64 bands, and these 64 bands can be combined to get some visualizations and analysis. I hope we are all. I want responses so that I know that we are all together. Excuse me. Can you all unmute that, please?
I'm with you. Good evening.
Can someone please unmute and speak? You are speaking, I can't hear you.
Well, I'm with you. I'm with you, yeah.
Okay, thank you.
Don't say that
So
your network
let's
is
continue.
actually bad.
In Williams. Which one of you is speaking?
Samuel is the one speaking.
Okay, are you trying to say something?
Yes, I said your network is actually bad. It's breaking.
I am breaking.
Yes.
Sorry, I didn't get you.
But you can go ahead.
Somehow low.
You can go ahead. You can go.
Okay, so moving forward, what is this satellite embedding like? What does it provide? Now, you don't need season with it. It's just like if you want to do, let's say, flood susceptibility mapping, you know that you would need vision and some climatic features like rainfall or temperature, and the satellite imageries you'll be picking might be used for your flow susceptibility mapping, might span more imageries, and you will have to try to fix in all these images. But with this, you don't need any of this preprocessing or anything, or combining everything together, because an embedding that has already prepared for you to just visualize. Analysis ready data set in Earth Engine. That means we can access this data engine, and that's why we'll be doing our hands-on session on Google Earth Engine. It includes them for the entire year. So if we see it, when we go to the hands-on session, the present feature that was released is version 1. So it's version 1, and it includes temporal context for the entire year. What does temporal context means? How many entails the resolution, or it entails how or the number of times this data are being captured. It's spatial context, which means it surrounds like its interactions or neighboring pixels. It understands it. Cloud maxing, there's no need for spectral transformation and any corrections. So it is a ready to use analysis. Now, one image per year has 64 bands, which you can play with and try to manipulate for your. Now, the image can be used in a variety of downstream tasks. For those that are conversant with machine, there are some models that are general purpose models. Yes, let's call this as a general purpose model that can then now be more fine-tuned or more use best cases. And what are these kind of use cases? You can use these satellite embeddings. We can use them as most importantly, or most generally used, is for classification. Use it for clustering and then change detection as well. We can also use it for crop type identification. So now let's go to unsupervised learning. This is doing, which is unsupervised learning on Google Earth Engine to get our data set. So I'll stop sharing to share my screen. Please, pending I try to bring up my screen. If you have any questions, please do let me know.
Speak, you cannot see. You can also just pause. You can type. It's okay to type. It's okay, but we'll pick it from the chat. So we can just. There are things I want to believe that at least our facilitator has mentioned one thing or the other. So there are things you feel that what's that? I don't even understand that. What's that called? What's the meaning of that? So it's a good time to go for the answer session to just speak right now. So, okay. So I will believe that we've understood all of the things that we have been hearing about the satellite imagery, the bands, the combination of bands, and all of those things. Even though you are not, if you are not familiar with all of those things before now, I think we now have understanding of how these things work and how numerous data sets we can get. You see a combination of so many things, so many bands together to form one embedded one, so to give us a very solid kind of data set, for us. So all of these things are the things I will get. So I will just, since we don't have questions now, so our facilitator screen will be coming up shortly, so that we can go to the answer session. Over to you, sir.
Okay, so please, can you all confirm you can see my screen? Can anyone confirm? Please.
I can
Yes,
see
we
your
can see
screen.
your screen.
I can see your screen.
Awesome. Thank you. So this is interface. Let me do a quick what the interface is. So this is this place you see all your these assets are where your data sets and some other this document contains, let's see, contains some of your documents as well. Assets contain imputed or imported into this Google Earth engine. Over here is where you're going to see some of your print results and then go to console for it. So now, as data that we want to use, but before we go, the first thing I love to do is to define my area of interest. That is my area of I'm concentrating on. And for this demonstration, we'll be using course in Nigeria. So instead of me or making use of any assets I have, such as the state boundaries or Nigerian boundary or any, I decided to use a custom one that is embedded or that is Google Earth Engine platform, which is the FAO Goal Simplified Level Data. It provides administrative level data at different levels for every country. To make use of it, I just called it. So you can do FAO here. So you will see the different distance, and then you see which is for state level, I guess level 1, first level, first level is for state, and I guess this one is for GAs, while this one is for the country boundaries. So I'm using the one in the level 1. Okay, but that's not the focus for this. In the I filtered it for Nigeria, and then in Nigeria also filter. So this is just to show me my of interest. Okay. Apologies, please. I would have to log out because I'm not signed in right now. Is an open source platform that provides computation data sets free of charge. Your special data set is free of charge. I really do love this platform because instead of going through the normal of maybe downloading your satellite imagery from all these platforms such as and the likes, here you would easily do your analysis, get your data sets, easily do your pre-processing, easily do your analysis, upload or send your data or even your results as you wish. So before it was not showing my email, so all this stuff was not so I could not run anything. So as I was saying previously, this is my area of interest. Then after filtering, I now said, okay, send Lagos. Let us run. And I specified the zone. This 10 is the zone. So this is Lagos now. This is Lagos. So if I now want to add it to my layer, add to layer. Okay. So now you can have of Lagos clearly like this. So now the satellite embedding that we are much focused on is to search for any data like you've seen previously. I just come here and say Google. Then, okay, Google Satellite. So it has brought it. So import. But since I've already put it here, if I should say import, it's going to bring it here. I don't want it here. So now, saying that my embedding is equals to image collection. So it's what excuse me, please. What this embeddings? So you are creating a variable, and that engine works by you using Java. It has its own. I can say it's somehow relating to JavaScript, but instances whereby it doesn't really tally with JavaScript. So to specify variable, you just say var. Yeah, that's the very embeddings equals to image collection. Then this, I can actually convert it that it will now be that way previously. So now for my VAR, I'm now saying I'm interested in year 2024. I'm now saying start date and end date. Now at this point, I am now trying to fill, because it contains the whole is a global data. What happens is that I need to filter it for my own use case and what I'm saying equals to filtered embeddings equals to embeddings dot filter by date and then filter by bounds, which is equals. Then give me this my, let's say after it has finished filtering, since it is stored or represented as different, this embeddings is being done in terms of tiles, different tiles for it. Once we get different tiles for it, we now want to turn the tiles in. When we now for us to turn the tiles into just one tile, because we don't different tiles, we just want to work with one tile. We will now do dot combine every tile that is in our image for us into one. I'm going to print embeddings. Then let's now visualize it. Code to visualize. Let's now run. So we are adding it to our map layer so that we are going to see how it looks like. You can see this is our satellite embedding. Without even doing anything, or without even, just by inspection, we can see that water body, all these, will I say hash color, our water bodies, someone or purple are this aspect. So interesting thing about Google Earth Engine is that we can put on map, and then let's see here that all here are like vegetation. All here like vegetation. Can we see? So now so we can see that all these purple things are like vegetations. That means it has been able to capture vegetations for us. Then all these green things, what are these green? You can see green and somewhere like blue, all these things. Let's put it off. You can see that they are buildings. These are built up areas. Just by inspection, you can see a lot. And then you can see that maybe this is also water or yes, water or living areas. So now we've seen our embeddings, but we cannot now, so in the embeddings, for us to, we can actually do inspection. And this inspection that we want to do, okay. So let's just inspect this place. This is where it becomes interesting. When we click on this place, we can see the embedding image here that's giving us the values for each of all these bands. Now the embedding image, the bands, you can see that it has 64 bands, and all these 64 bands have the same coordinate reference system. So for this visualization, we only combine band 1, band 16, and band 9. But now let us try to make more meaning about this embedding. Let's see how we can make use of it, and that's where the supervised learning comes in. So in supervised learning, what does supervised learning do is that it is a self-learning. It's going to learn on its own. Once it learns on its own, it's just like you are training it to learn patterns from this data. What is it going to learn from these patterns? It's left to it. It's going to learn from the data. It's going to pick patterns from it, and then it's going to give us results. Now let's learn patterns from it. We now try to now look at it, because one model we can use to learn patterns, we can use for this clustering is k-means. And then let's try to run this k-means by giving it 1,000 samples. So we've done that. So it's telling us our bands. It's printed our bands for us. Now let's now look at it. We have created, firstly, we have quickly, we've already created our cluster model using k-means here. If you can see it here, we've used k-means. Now, from this cluster model that we have created, now let us now tell it that from this, our cluster, from what you have learned from this, now divide 3 clusters from all these 64 bands that we have, that you know that you have understood. Now give us, now from all these features, now give us 3 features. Classify everything into 3 for us. Now let's see what it's going to do. So from here, you can see that it has now clustered this into 3 for us. And what did it cluster it for us into? We have, excuse me, please. Here, you can see that the pink areas are rivers. If we turn on our satellites, you can see that the pink areas are rivers up to here. These are rivers. Now let's see what the yellow parts are. The yellow parts are thought to be, you can see green parts. Green parts are mostly built up areas, while these yellow parts are like vegetation. So now this is not 100% accurate, because as you can see, there are some built up areas here and there are some vegetation here that it is also picking as, it's also mistaking them. This is just to let you see the power of it. So now we've seen it to cluster, to give us 5 clusters. Let's now tell it to give us 5 clusters. We've told it to give us 3 clusters. Now let's tell it to give us 5 clusters. So as it is loading, we are going to put this off. Awesome. So it is loading now. In these 5 clusters now, we can see that we have this black area here, all this black area. We also have this water, which is in pink, which is pink color. Then we have, what is this? This brown. This brown. We can also look at this brown. This brown is vegetation, as you can see here. Then we can see here that, let's say this black is built up areas and the lights. So now from what it has learned, it has been able to classify all these things for us. Now let us also tell it, let's tell it to classify this. Okay, what did I press? And on comment. So now let's now tell it to classify this into 10 classes for us, and we will see it. So this is for it is a use as on the go tool, like data set. So instead of me doing this normal clustering calculation, before I do this normal clustering calculation, I would have done a whole lot of, before I now think of what kind of thing I'm going to use on it. But now this embedding has made it very, very easy for me to just use the embeddings directly. And to create clusters, you know that you would have had in normal machine learning, you will have many features, many years data to feed this model. That means it has reduced the computational stress for me in trying to carry plenty years of data into this my k-means model, for it to be able to now understand the data and now predict and or cluster, to understand the clusters of the pixels for me. Now, with these satellite embeddings, it is very, very easy and seamless for me to do. So with this, we have come to the end of today's class. Other use cases, as you have made mention of previously, is crop type monitoring or crop type classification as well. We can also do, there are other lots of applications that we can do with it. So because of our time, we'll be stopping here. And if you have any questions, please, you can ask now. Thank you.
So for me, I know there's no doubt we have enjoyed this class, and because I've enjoyed it, you could see a lot of stress that would take even weeks, whatever it is, stress, and then a lot of data, set computation, and all of that, and then we are just being able to do it by embedding and using our foundational model. So, and it's a whole lot. Some of us want to ask questions, probably maybe what's this, but you already see how it's not a mouth thing. So, and ask your questions. When you feel like you can drop it on the group chat. We are also, and with the fastest group chats that will be able to attend to it, and you know that on this general group chat, there's a lot of message that comes in. But on our own geospatial community chat, we are like just direct, whatever you ask, no extra message covering them. We are able to attend to you as fast as possible. So that's why we'll be dropping the link. So this general chat, so I can join the access questions. So this class is recorded, just so you may know, and so you can always access it on our YouTube channel. Like, subscribe, and I want to appreciate, first of all, our facilitator for today, in person of Sarah Peter Dewey, for taking us through that wonderful class, and everyone who has joined us today. Without you, we won't be having this class. See you some other times very soon, and then do enjoy the rest of the day and the weekend. Thank you. Bye.
Thank you.